Hi, this is Beth Rosengrant on our last final video. Our first problem is subtracting fractions. Why do we have to find a common denominator? You have to find a common denominator while you're doing fractions because it's the only way to show the same size or to make it fair. It's impossible to subtract two fractions that have different numbers of parts. So let me show you what I'm talking about. I'm thinking of a number 5 sixths minus 3 twelfths. Can't do that because they don't have the same parts. So we have to find the least common denominator. And for this one, it's 12. So we're gonna come down here and do 12 underneath. And we know that to get 12 from 6, you had to subtract times 2. So what you do to the bottom, you have to do to the top. 5 times 2 is 10. We know that 12 is only by 1, so then you only have to take 3 times 1. So look at this. Then we have common denominators, so we can do, now we know the answer to this one is 13 twelfths. Let me show you an example of why we have to have a common denominator, how you can think about it. Think about 2 candy bars. You are at the store and your mom bought 2 candy bars. She bought a king size candy bar and a regular size candy bar. You can see that these 2 candy bars are definitely a different size. So if she told you, Michael, that you were gonna get half of a king size bar, and that you then, Teresa, you're gonna get half of the regular size bar. Wait a minute, doesn't this half look way huger than that half? That's why we can't subtract these, because they're 2 different sizes. You need to be able to do 2 regular size candy bars. So it makes the problem fair. Same size, makes it fair. You have to find that least common multiple to be able to make it fair. Okay, our next problem is going to be math vocabulary. We are looking at different ways words are used in everyday speech and then used in the context of math. So the first word is difference. If you're talking about difference in real world, you think of different, like she has different hair than the girl beside her. The difference meaning that it's not the same. But when we talk about it in math class, the difference is from a subtraction problem. The difference is subtraction problem. When you take the minuend minus the subtrahend, you get the difference. So in math, difference means an actual equation. When you're talking about in everyday life, it's just not the same. Look at another word, base. In base, if we think about a base in everyday language, we're thinking of like the lowest part of something, like the base of a tree, the base of your shoe. But when you're talking about base in math language, you're talking about the total number of digits in a number system. Totally different than the bottom or the base, the lowest part of something. Another word is product. When you are thinking about product on everyday life, you think of something you get from the store, an article or substance, something you have in your hand. But when you're talking about a product in math, you're talking about multiplying 2 or more numbers to get a product. That's what you get from multiplying. Addition, in everyday language, you're talking about adding something. You're adding to something. You're going to add an addition to your house, like at your mom's house. If your mom decides to add an addition to make it bigger for your grandparents to move in, you're making an addition. But in math words, you're combining 2 or more numbers. Addition is combining 2 or more numbers, 2 addends to get a oh my gosh, I forget what it is. Addend plus addend equals, I don't even know. I'm going off topic. But anyway, so when you have them in different words, and then sometimes you can get mixed up with words. We have a lot of times where you can ask me a question. What is it? Isn't it funny if I say, okay, we're going to get ready to do our math lesson. We're going to rev up our math brains. You really don't have a math brain, but we're using that to help us get excited about math. So there's different ways that you can use the words, but there's a lot of misunderstandings that can come. So always remember to ask questions. The next one we're going to talk about is mean, median, and mode. We have 5 different prices for a home. I'm going to go ahead and while we are discussing these, I'm going to go ahead and put them in order from least to greatest. So we have 5 different prices: $205,000, $374,000, $389,000, $352,500, and $376,000. So I'm going to first, because I know that's part of this problem, put them in order. So my first is going to be $205,000. My second is going to be $352,500. The third one is $374,000. Remember, I'm putting these in orders from least to greatest. $376,000. And then my greatest is $389,000. So you can see I've listed these from least to greatest, because that's going to help us when we're doing our problem. So the first thing we want to find is the mean. And what we do to find the mean is we take all 5 of these numbers and add them up. Add them up. And we are going to get, because I already did this on my calculator, 1,696,500. Now we know to get our mean, then we need to divide it by how many numbers we have. We have 1, 2, 3, 4, 5. So with our calculators, we would take 1,696,500 and divide it by 5. I've done this already. These are big numbers, and I just did it with my calculator to help you. I wanted you to be able to see what we're doing. Then this number is the answer to that. So now we know our mean is 339,300. Now we are supposed to find our median. Median also sounds a little bit like medium or middle. So how do we find the middle when we have 5 numbers? Because they're odd, we just go through the middle. 1, 2, 3, 3. This is our median. $374,000 is our median, the middle. How do we find the mode? Mode means most frequently used. In other problems, we might have smaller numbers, 7, 8, 8, 8, 9, 11. So we would know that these are the numbers that are used the most. So that would be our mode. But if you look at our numbers, we have 5 prices of homes, and none of them are the same. So for this particular problem, we don't have a mode because there are no numbers that are the same. This is not a mode. We cannot find a mode on this problem. The next problem we are going to do is looking at confusing notation and vocabulary. There are a lot of times when things are written and we don't know what they mean, but they all look the same. So we have this one, just 2 divides 10. Now look at another one. What is that one compared to this one? So this one we know is 2 divides 10. This one is 2/10 or 2 divided by 10, which these two are literally the same. 2 divided by 10, 2 divided by 10, 2/10, 2/10. They're the same. This one is 10 divided by 2. And then we have this last one, which is 2 times the square root of 10. Look at all these different ways that things are written, but that they mean. This line has to be straight to get it to be 2 divides 10. This one is more crooked, so then it becomes 2/10. This one is a fraction, obviously. This one is a division, and this one is square root. How about if we do another small one? I think I'm actually going to stop the video right now and do another video.